From the rhythmic pounding of Cailun's papermaking to the varying carvings of Bisheng's printing with movable type, from the magnetic wisdom embedded in the Chinese compass's ladle to the spark of exploration ignited by the gunpowder formula, these are not just the legends of the four great inventions, but a scientific epic meticulously crafted by the hands of countless Chinese artisans and craftsmen. Every stroke of ink on these stamps embodies the devotion to celestial observation, the toil of taming floods and digging canals, and the ingenuity that rivals nature itself. While the four great inventions kindled the flame of human civilization, the river of wisdom flowing through the lands of China has long surged into grander tides, measured in sundial markings, arched in stone bridges, and woven into the warp and weft of looms.
In this episode, let us step into the China Science and Technology Museum and, through these miniature postage stamps, hear the seismic echoes reverberate from bronze toads. Witness how technology permeated from imperial courts to everyday life amidst cotton patterns and celestial tracks.
虽古之处，谁传道之？上下维系，何有告知？明朝梦暗，谁能记之？平以微笑，何以视之？天可索他，时而言分。烈性暗沉，东西南北去修疏多，南北顺脱，几言几何？有些敢问无限，人心敢问人间，造物悲悯千万年，年年有人问天。星海若尘埃旋转，把生灭因果都写进繁衍，春秋逐渐中长谈。
For millennia, the diligent and ingenious Chinese nation accumulated vast experience through interactions with nature, achieving scientific inventions that led the world. The stamp before you displays a reconstructed seismoscope, the world's first earthquake detection instrument invented by Zhang Heng of China's Eastern Han dynasty to identify seismic epicenters.
The year 132 AD saw the creation of the seismoscope by Zhang Heng, marking a brilliant chapter in the history of humanity's battle against earthquake disasters. This exquisite stamp illustrates the intricate seismoscope. The seismoscope's internal structure was very intricate, primarily consisting of a central pillar, similar to an inertial pendulum, and the surrounding 8 paths, 8 sets of lever mechanisms installed around the pendulum and connected to the instrument's body. On the outside, 8 dragons were positioned at 8 cardinal directions. Each dragon's mouth contained a small bronze ball, and beneath each dragon's mouth was a toad with its mouth open, facing upward. If a strong earthquake occurred somewhere, the seismic waves would cause the central pillar to tilt, triggering the lever mechanism of the dragon at that direction. The dragon's mouth would then open, and the bronze ball would fall with a clinking sound into the toad's mouth below. Observers would then know the time and direction of the earthquake by the sound of the falling bronze ball. While Zhang Heng's bronze seismoscope was still listening to the heartbeat of the earth, 3,000 miles away, another kind of vibration was changing the warmth and cold of the human world. The sound of Huang Daopo's innovation of the three-spindle spinning wheel seeped through the Jiangnan region, like spring silkworms devouring leaves. The seismoscope protected the peace of the mountains and rivers, while the cloth woven in Songjiang weaved the quiet years of the people amidst the changing seasons.
This stamp recreates the likeness of Huang Daopo, China's renowned female inventor, a textile innovator of the Yuan dynasty from Songjiang. She spent her youth in Yazhou, mastering weaving techniques before returning home to revolutionize textile tools. Her teachings on cotton gins, bowstring devices, spinning wheels and looms transformed Songjiang into a thriving textile hub, advancing cotton cultivation and weaving technology.
This 13th century female scientist wrote a textile legend with her life. As a young woman, she was stranded in Hainan's Yazhou, where she spent 30 years mastering the Li'an ethnic group's wrong thread color matching technique. In her later years, she returned to her hometown in Songjiang, where she innovated the cotton pressing machine, three-spindle spinning wheel, and jacquard loom, increasing cotton cloth production efficiency by 10 times. Her work, the Cotton Spinning Sutra, standardized the 4 processes of defending textile weaving, enabling Songjiang cloth to clothe the world. Her contributions helped the Yangtze River Delta rise to become the global center of the cotton spinning industry. While Europe was still hand-spinning threads, her multi-spindle spinning wheel had already set the stage for mass production. When the cotton fabric of Songjiang was swept by the salty winds of the maritime Silk Road, a subtle harmony emerged between Huang Daopo's three-spindle spinning wheel and Zheng He's compass. One, weaving the warmth of daily life through the threads, the other measuring the world's expanse through its watertight chambers. As the treasure fleet set sail with its 27,000 crew members, they were clothed in the cotton garments crafted with Jiangnan's pioneering weaving techniques, while the intricate porcelain designs hidden in the ship's hold still seemed to carry the distant echo of the wooden gears turning in the cotton carding machines. In 1405, under the orders of Emperor Yongle of the Ming dynasty, Zheng He led a vast fleet of over 27,000 men from Liujiagang in Taikang, embarking on diplomatic missions to countries and regions west of the South China Sea. This journey became known as the 7 Voyages to the Western Oceans. Over a span of 28 years, Zheng He's fleet sailed to more than 30 countries and regions, including Southeast Asia, the Indian Ocean, the Red Sea, and the northern coast of East Africa, achieving a monumental feat in the history of human navigation. Zheng He is celebrated as one of the greatest navigators in world history, a figure whose legacy continues to be immortalized.
These crisscrossing wooden bulkheads conceal ancient China's greatest maritime survival code, watertight compartment technology. Craftsmen divided massive ships into 12 independent watertight sections with transverse bulkheads. Even if breached, sealing the damaged compartment kept the vessel afloat. Zheng He's 7 ocean voyages without major shipwrecks relied on this unsinkable technology, predating the West by 400 years. Remarkably, these camphor wood partitions also served as longitudinal ribs, achieving perfect structural integrity with minimalist design.
While Zheng He's fleet was still measuring the vast seas and skies, Guo Shoujing's armillary sphere had already marked the cosmic coordinates for this great feat. The watertight compartments protected the ship as it cut through the waves, while the armillary sphere calibrated the compass, guiding the nation's exploration of the unknown. What you are now seeing is a replica sculpture of the armillary sphere in front of the National Museum of Science and Technology. Guo Shoujing, a renowned astronomer, hydraulic engineer, and mathematician during the Song and Yuan dynasties. He built the most advanced astronomical observatory of his time and created nearly 20 astronomical observation instruments. In order to accurately collect astronomical data for the development of a new calendar, Guo Shoujing spent 2 years meticulously designing and manufacturing a complete set of astronomical instruments, comprising 30 pieces. Among these, the most innovative were 3: the Gao Biao and its auxiliary instruments, the Ji Yi astrolabe, and the Yang Yi zenithal instrument. He was also an expert in hydraulic engineering. He compiled the Shoshili calendar of timekeeping, which determined the length of a year as 365.2425 days, differing from the actual number of Earth's orbit around the Sun by just 26 seconds. Guo Shoujing is one of the 8 great scientists of ancient China.
From the 28 lunar mansions mapped by bronze armillary spheres to Tianwen-1's trajectory across Martian skies, from the azure wake of Zheng He's treasure ships to the Mariana Trench explored by Jiaolong submersibles, China's dream of conquering stars and oceans continues undimmed. The ancient wisdom encrypted in these stamps now manifests as Beidou's positioning signals, quantum computers' entangled photons, and space station solar arrays, showing Chinese people's eternal passion about exploration, invention, and innovation.